Hello, everyone. Thank you so much for your time today. My name is Senthil Avinash. I'm one of the solution engineers here at Postman. And today I'm going to talk about how you can integrate your existing APIs into a rapidly evolving AI marketplace. Before we do that, let me first introduce myself. My name is Senthil Avinash. As I mentioned, I'm one of the solution engineers here at Postman. I specialize in evaluating organizations' API and workflows and help in identifying how the Postman platform can deliver tailored solutions that maximizes business value and success. Prior to Postman, I worked for several organizations in the past, including Salesforce and Guidewire, where I enabled financial services and insurance carriers with API-led connectivity to core business transformation solutions. Outside of my professional career, I love giving back to the community. I volunteer at the Ronald McDonald House's charities, where I capture photographic memories that supports children and their families. I'm based out of Denver, Colorado. I love the outdoors and enjoy hiking and biking in the Rockies. Now let's take a step back to talk about how the AI is evolving. In today's world, pretty much everybody relies on some form of LLM or AI agent to get their work done, right? Whether you're trying to compose that email to polish that content, creating a presentation, or simply writing code or test cases, there's definitely some amount of LLM invocations that can come into play. What stands out is how rapidly these tools have improved in a short span of time. This progress is partly driven by smarter training techniques and richer data sets that make the models more knowledgeable. However, one of the key breakthroughs from a prompting perspective has been the chain of thought prompting. This approach enables models to generate step-by-step instructions of their reasoning before arriving at a final answer, leading to more accurate and reliable outputs. To make this reasoning even more effective, models will need access to exponentially more tools and data sources, enabling them to reason any type of problem. As you can see, there's a need to increasingly integrate with several external APIs now, thereby fueling a rise of a new kind of AI marketplace. One that brings together AI services and targeted workflows, allowing customers to seamlessly plug in into their existing LLMs. So the result is a simplified AI development process coupled with the creation of powerful context-aware applications. Now let's talk about the integration challenge that many LLMs face today. For example, Gemini can interact with a range of Google services, right? Whereas OpenAI can access files, browse websites, capture images, etc. And when building your own AI agent, there's a need to be able to add custom functions to call external APIs. However, integrating these functions poses a significant challenge. These integrations are typically limited and must be manually implemented or hand-coded for each integration. There's no standardized way for LLMs to easily plug in additional capabilities. This creates a classic M by N integration problem, where each model M requires custom code to connect with each tool or data source N. And as the number of AI agents and external tool grows, this approach quickly turns into a tangled web of connections, a spaghetti mess that becomes increasingly difficult to scale and maintain. So the M by N integration mess that we were just talking about, the complexity, the brittleness, and the slow development cycle is clearly unscalable. What's needed is a standardized way for AI models to connect with external tools and data sources. This is where the Model Context Protocol, MCP, comes into play. So think of MCP as the USB-C port for AI, a universal standardized interface that allows LLMs to seamlessly plug in into a variety of services and tools, So instead of building custom integrations for every model to service combination, developers can now rely on a single standard protocol. AI models need to understand MCP, and service providers, whether it's a CRM application or an internal system, can expose their functionality through a MCP compliant interface. So this dramatically simplifies the integration landscape now. Rather than M models now connecting to N services individually, all participants now connect through a common standard. This significantly reduces complexity, accelerates development, and enables a much more scalable and maintainable ecosystem, ultimately bridging the gap between AI and the real world. Now that we understand what MCP is all about, let's look at its architecture and its key components. At the core, you have the MCP host. So this is your user-facing application where the AI resides. Think of this as your app like Claude, a development environment like Cursor, or a custom AI agent you're working on. It's the interface where the user interacts with the AI. Within the host is the MCP client, which acts as the host's dedicated communicator. The client is embedded within the host and is responsible for managing the connections to external services. So it maintains a one-to-one connection with each MCP server to initiate requests, receive responses, and passes the results back to the host. On the other hand, we have the MCP servers. So these are lightweight applications that expose specific business functionality, typically through APIs in a standardized format. These servers represent external tools or data sources to expose business logic, such as checking for your order status, querying customer data, and have those functions accessible to clients. And finally, the MCP standard itself defines the rules of engagement, how the server describes its capabilities, how the clients discover them, and how these functions are securely and consistently invoked. This structure ensures seamless, scalable, and standardized interaction between AI models and external systems. So having understood the architecture and its core elements now, let's dive into a standard communication flow, starting from the host, moving through the client, and finally invoking the server. So the user interacts with the host, submits a query. Then the host determines which external capabilities are needed. The host directs the client to connect to those appropriate servers. And then the client queries the server for available tools, prompts, and resources. The host then talks to the client to invoke those specific server capabilities. The server then performs the requested action, which could be an API invocation, and returns those results to the client. The client relays these results back to the host, which can be your LLM app or your AI agent that you're working on. So as we saw from the flow communication side, APIs now play an integral part of tools exposed via MCP server. For example, when an LLM selects a tool to use, the tool could be making a specific API call based on your business requirements that it returns the response back to the model. And with these rise of AI agents now, whether it's ChatGPT, Claude, GitHub Copilot, or custom agents built for specific business functions, these agents now represent a growing category of API consumers now. They require programmatical access to your services, databases, your internal systems, code repos. This marks a significant shift in the purpose of APIs. For years, we focused API consumption by primarily human-facing UIs or enabling integration by other developers. But now, APIs are increasingly becoming the de facto primary interface for intelligent systems. Ensuring your services are easily discoverable and usable by AI agents is no longer just a technical optimization. It's becoming essential for relevance in this new AI era. We want to make sure that these APIs are easily discoverable, well documented, and consistently maintained. So if MCP provides that standardized connection, and AI agents are emerging as powerful new API consumers now, what does it mean for engineering teams building and managing these APIs? First, we need to recognize that APIs are fundamentally evolving. They're no longer just contracts intended for human developers. They are becoming direct functional interfaces designed to be understood and operated by AI agents. And this shift introduces a new set of design principles. So rather than thinking in terms of raw endpoints now, we need to be able to start packaging capabilities into logical tools, actions that the AI can take, resources that the data or the object that the AI interacts with. These must be structured in a way that AI agents can easily interpret and use reliably to achieve results. Equally important is machine-readable documentation. Agents require structured metadata, clear description of what the tool does, what input it expects, what output it produces, and how it handles errors. This is exactly why MCP includes its own standardized format for describing capabilities, enabling precise discovery, interpretation, and usage by AI agents. And finally, this shift redefines how we measure API success. It's no longer just about developer signups or human usage. Success must now also take into consideration how effectively and reliably these AI agents are leveraging APIs to perform tasks and deliver value. So preparing our APIs for this new era of machine-first consumption is not just important, it's absolutely crucial. So let's talk about some of the steps to consider in order to make your APIs ready for MCP consumption. You need to expose them in a way that MCP-compatible clients can easily discover and invoke them. And the first step is to establish a curated, centralized platform that allows your team to quickly discover and reuse assets based on functional domain or use cases. Next, document your APIs using an open API specification, a standardized format that enables MCP tools to identify and describe your endpoints, your parameters, your authentication methods, and response formats. Then enrich your API definition with strongly typed properties to enhance the generated documentation. And once you've created an API skeleton aligned with your client's business requirements, you can then begin testing it, monitoring it. Gathering early feedback from your team is absolutely key for success as well, and iterating continuously to improve quality and usability. Let's take a quick peek at MCP security best practices now, tailored for both developers and users. On the developer side, it starts with strong authentication and authorization. So implementing standards like OAuth 2 and enforcing role-based access permissions. Data protection is also critical, ensuring encryption is performed both at transit as well as at rest. We also emphasize API hardening through techniques like rate limiting, IP allow listing, and strict input validation. And finally, a secure CI/CD pipeline is essential, scanning dependencies and integrating security testing throughout the development lifecycle. On the user side, security begins with strong identity management, using MFAs and safeguarding credentials. Applying the principles of least privilege ensures users access only what they need. Prompting security awareness with hygiene helps users avoid phishing attacks and maintain updated systems. Lastly, data privacy controls allow users to review what is being shared and with whom. Together, these practices form a strong foundation for secure API and platform interaction within the MCP protocol. MCP is rapidly gaining real-world traction and building significant momentum. Originally developed by Anthropic, now the standard is seeing strong adoption from major players like Microsoft, Google, OpenAI, for example. And it's just not limited to these foundational model providers. Companies such as AWS, GitHub, Hugging Face, for example, are also actively integrating MCP into their ecosystems. And developer tools, I should say, like VS Code, Cursor, Windsurf are also embedding MCP, bringing its capabilities directly into the developer workflow. One of the clearest indicators of MCP's growing impact is the explosion of community-built MCP servers, reflecting both widespread interest and a broad range of use cases. For example, Pulse MCP is a community-driven hub for the MCP ecosystem, which lists over 4,000 MCP servers, making it easy to discover and explore available servers, clients, and applications. And Postman includes an MCP catalog as well. It's a public workspace of curated, ready-to-use MCP servers that allow pre-built integrations from several APIs listed on the Postman API network. That includes, for example, PayPal, Stripe, Notion, Slack, and many more. Easily discoverable, ready to test from these verified publishers. So what are some of the priorities to consider when we start thinking about building next-gen AI agents? First is enabling AI interaction through a standard like MCP that we just discussed. You make your entire platform much smarter, more adaptive, and future-ready. And getting this right honestly positions your organization for the future. Second, it unlocks the full potential of your company's services. When your APIs are easily accessible to AI agents, these systems can leverage your tools and data to drive real outcomes, automating tasks, enhancing productivity, and delivering that business value. Third, there's a tangible risk in waiting, right? So if your services are hard for AI agents to discover or use, your business risks falling behind your competitors, who may already be building more automated, intelligent, and scalable solutions. So the bottom line is clear. Deciding how your company's services connects to the AI-driven world is no longer optional. It's a critical step to stay competitive, relevant, and ahead of the curve. So now is the time to act. So to wrap up, I recommend the following steps to start prepping your teams for the AI era. First is to educate, right? Start with the basics. Help your team understand why APIs need to be AI friendly and what it means to design for machine consumers. This includes new patterns like tools, resources, and structured metadata. Second, evaluate. Review your existing APIs. Identify which ones are most valuable or most likely to be used by AI agents. Choose a few high-impact candidates to begin with. Third, experiment. Start small. build a prototype MCP wrapper around one of these few key APIs that you identified. And this hands-on approach, I tell you, will help your team learn more quickly and validate that concept. And finally, leverage context-aware API platforms that enable AI-focused features that adds MCP support. And these tools can accelerate development and make your integration testing much faster. Again, thank you so much for your time today. Really appreciate it. Feel free to scan the QR code on the slide to connect with me on LinkedIn. Happy to dive deeper into any topics that we covered today. Thank you so much. Have a good day.